Hello, assalamu alaikum, viewers and dear candidates. Today we are going to learn about first year book exercise. Question number 1. Simplify the following terms. First question we simplify. For third we simplify in question number 1. -1 minus 23 over 2. How we can simplify? We know that iota square is equal to -1. In place of iota square, we put -1. -1 is already given, so we put iota square. Iota square minus 23 over 2, both are cancels. So the term is reduced, -23. Now we can write this term 1 by, we change into the positive according to the rule x power -1, so we can write 1 by x. So here the power is negative, we change into positive. According to this formula, our rule we can reduce. Now we change this term, how we can simplify in the easiest method. 2 ones are 2. 0 to 1 multiplied by 2, we get 1. Here we reduce this term and iota power square, exponent is 1. Here but actually quotient, so we can write quotient in the power, remainder is equal to here 1. So it means that we can simplify this term. 1 iota power 23 is equal to, we can write iota square whole power 11 into iota. Once again we put iota square is equal to -1 power 11 into iota. So here the power is odd number, we get minus iota. Now we can also take the conjugate of this one, because in the denominator this complex number is coming. So we try to take the complex number, we divide and multiply. Here we divide and multiply by the conjugate of 0 minus iota. So the result will be plus iota. We already discussed in the complex number. So here the imaginary part is changed into positive. Now we reduce this term and minus iota into iota. We multiply and also divide by this term. So numerator is also multiplies to each other. So we get iota into iota square. So the result is iota minus iota square is equal to 1. So iota into plus 1 is equal to iota. On the same question, 4 part -1 15 over 2. The same process here, iota square is equal to -1. In the place of -1 we put iota square 15 over 2. 2 is cancel, we get 15. So how we can write this one? Iota square power 7, 7 2 is 14, and also iota. Now we can put -1 power 7 iota. So here the power is odd number, so we get odd number. -1 into iota, we get answer minus iota. Now we are taking left hand side. We want to do that. Taking left hand side, iota power 107 plus iota power 112, iota power 122, iota 153. We want to have to do that the result will be equal to the right side equal to 0. we are using the easiest method. How we can simplify 107? We can simplify 2 5 multiplied by, so we get 10. 7 is remaining here. 2 3 multiplied by 6, remainder is 1. So we can write iota square exponent 3. This will be power. Here we put, this is also quotient, but we change into the power. So here remainder is multiplied by 1. Now the second term we can write 112. Similarly, we divide this one to 5 multiplied by 10. We get to 6 multiplied by 12, so remainder is 0. We can write this one iota square whole power 56 iota 0. So iota square 56, anything to the power, so the result 0, so the result is 1. Similarly, we 122 we simplify to 5, so we get 12. 12 minus 10, 12 minus 10 is equal to 2. 2 to 6 multiplied by 12, we can write to 6 multiplied by 12, so we will write 0. 2 ones are 2, so result is 0. Now we can simplify iota square over exponent 61. Similarly, iota 0 is equal to 1 iota square power exponent 1. Similarly, if we simplify 153 to 7 are 14, 1 to 3 to 6 are 12. So here is 1. Remainder we can write iota square exponent 76 into iota 1. Now we substitute these results according to the simplification. We can write iota power 1 itself, we can simplify iota square 53 into iota plus iota square 56. Similarly, iota square, here we can write 112 56, this one, and 122 we can write iota square 61 plus iota square 153, we reduce power 76 into iota. Now look here, we replace iota square. We know that iota square is equal to minus 1. So we replace iota square 53 into iota minus iota 56 plus minus 161 minus 1 power exponent 76 into iota. Now look here is minus 1. If we multiply by 53 times, so the exponent is odd number, so we get minus 1. Minus 1 is multiplied by iota, so we get minus iota. Similarly, if there is even number, if we minus 1 multiplied by 56 times, so we get plus 1. Similarly, here is minus 1, and here 76 is even number, so minus 1 is multiplied by 76 times, so we get plus 1. Plus 1 is multiplied by iota, so we get iota. So minus iota plus iota cancel, plus 1 and minus 1 is cancelled, so this will be equal to 0. We get the required result right hand side. So hence we can verify that left hand side is equal to right hand side. 6, 4 plus iota plus 5 iota. Question number 6, part 1. We change into the formula a plus iota b. Now look here in the denominator term, complex number is coming, so we want to finish this term. It means that we take conjugate of these numbers, we divide and multiply by the conjugate of 3 plus 5 iota. So the result is 3 minus 5 iota. Here the positive change we already discussed. And the conjugate we always change every part of the symbols. Here symbol is positive, we change into negative. Now we reduce the word from 4 plus iota, 3 plus 5 iota, multiply 3 minus 5 iota, 3 minus 5 iota. Now we multiply the numerator terms to each other. 4 into 3 minus 5 iota plus iota is also multiplied 3 minus 5 iota. Now here we use the formula a plus b, a minus b, we get answer a square minus b square. Now look here, we use here the formula a square minus b square, 5 iota whole square. Now we reduce this term 4, 3 multiplied 12, 20 iota plus 3 iota minus 5 iota square. Iota multiplied by iota square. And here we can open this one 9 minus 25 iota square. Now we can simplify here iota and iota. These are like terms. 12 minus 17 iota minus 5 in the place of iota square minus 1. Divide 9 minus 25 in the place of iota square minus 1. Now 12 minus 17 iota minus into minus plus 5. 9 minus into minus plus 25. Similarly, here is real part, here is real part. So we get 17 minus 17 iota divided by 34. From the bottom, we checking common. 17 is common, 1 minus iota divided by 34. 17, 1, 7, 2 multiplied by 17, we get 34. 1 minus divided by 2, so we can write 1 by 2 minus 1 by 2 iota, which is the form of a plus iota b. That is the required answer. To Fz1 is equal to 1 plus 2 iota and Z2 is equal to 2 plus 3 iota. So what is the result? Z1 dot Z2 absolute and thus 2 and part third we can write Z1 divided by Z2 modulus Z1. We find the solution of this one. First of all, we consider the term here. We can write consider the term Z1 dot Z2. First of all, we multiply these two terms, then after the solution of this one, we take the modulus of this one. Z1 1 plus 2 iota and 2 plus 3 iota. First multiply 1, 2 plus 3 iota plus 2 iota, 2 plus 3 iota. Now open the brackets. 2 plus 3 iota plus 4 iota plus 6 iota. 2 multiplied by 3, 6 iota multiplied by 1 iota square. Now we change simplest form. 2 plus both are like terms 7 iota plus 6 minus 1, because iota square we know that minus 1. In the place of iota square we put minus 1. So 2 plus 7 iota minus 6 plus into minus 1 minus 6. Now this is real and this is real, we get minus 4 plus 7 iota. This will be the product of Z1 and Z2. Now we are coming to the modulus Z1 dot Z2 modulus according to the formula x square plus y square, or we can say that a square plus b square. Now the form is here a plus iota b. Here a is equal to minus 4 a square plus here b is equal to 7 whole square root. So minus 4, if we here is even number, we get 16 plus 49. 49, if we add this one, 6 plus 9, 15. 15 plus 1 is k 5 and 6, 65 is the answer. Now we are proceeding here. Consider the term z1 divided by z2. 1 plus 2 iota divided by 2 plus 3 iota. We have already in the previous question we have solved here. The problem is coming once again. Complex number in the denominator. We want to finish this term. It means that we divide and multiply by the conjugate of this one. So we can write directly here now 2 minus 3 iota, 2 minus 3 iota. Now the same process, if we multiply here 1, 2 minus 3 iota plus 2 iota, 2 minus 3 iota. Here we use the formula a plus b, a minus b is equal to a square minus b square. We directly apply the formula here minus 3 iota, a square minus b square. Now open the brackets in the numerator. 1 multiplied by 2, 1 multiplied by 3 iota, 2 multiplied by 2, 4 iota, plus into minus 2 multiplied by 3, 6 iota into iota square. And it's 4 minus 9 iota square. Similarly, we put here iota square is equal to minus 1 in place of this one, in place of in the denominator term. And this one is the like term. 2 minus, these are the like terms. Minus 3 plus 4 plus iota, minus 6 minus 1 divided by 4 minus 9 minus 1. Similarly, we simplify this one. 2 plus iota plus 6 minus into minus plus 4 plus 9. So here is the real 8 plus iota divided by 13. We can write this one 8 divided by 13 plus 1 divided by 13 into iota. Now this one is the solution of z1 divided by z2, but here the requirement is modulus. So now we take the modulus is equal to a square plus b square. This is the general formula of the modulus of any complex number. Here a is equal to 8 divided by 13 whole square plus and b is equal to 1 by 13 whole square root. Open this one, we can write 64, 1 divided by 69, 1 divided by 69 square root. Here we take LCM 169. So both are same LCM, it means they will directly get this one 65. So 65 under root at 169, we can write 13 square root. So 65 under root, both are cancelled, this one 13. This is the solution of the z1 divided by z2 absolute. Thank you very much for watching. Once again, we inshallah in the next video we solve the next topic and also exercise